The purpose of this video is to introduce you to circles, as well as central angles, inscribed angles, and arcs. I'm going to start first by talking about what a central angle is. A central angle is an angle that's formed by two intersecting radii in such a way that the vertex of the angle is at the center of the circle. We need to talk a little bit about naming a circle and where its center is and what radii are and all these good vocabulary things. The center of the circle is going to be indicated by a dot, and a circle is always named for its center. So in this particular case, since the point at the center of the circle is point O, we would call this circle circle, and that's the symbol that I'm going to use for a circle, circle O. The next vocabulary that you need to be aware of are radii. Radii is the plural of the word radius. You should know that a radius is a line segment that begins at the center of the circle and extends to any point on the circle. All right, so there's a little bit of vocabulary that you need to be aware of. So in this picture, we say that angle AOB is a central angle. Why? Because its vertex is at the center of the circle. Now, intercepted arc. We need to talk a little bit about what an arc is. An arc is just going to be a portion or a part of this curved area that makes up the circumference of the circle. The intercepted arc of this angle is going to be the arc that's bounded by these two radii. So if I go ahead and take a look at the radii that make up that central angle, the arc that's bounded by those radii is that arc, or that piece of the circle, from point A to point B. And we call that or name that arc AB, and that's the symbol or the symbols that we're going to use to describe that. Now, there's also an arc that starts here at point A, goes all the way around the circle the long way to point B. That's something called a major arc, and a major arc is more than 180 degrees. To name a major arc, we would have to name any 3 points on the arc. So I might make this point arc C, and the difference between the two is that arc ACB is a major arc. It goes greater than 180 degrees, so it's the big arc going all the way around the circle. The arc from A to B is this little blue guy in the picture. He's what's known as a minor arc. All right, something that's going to be really important for you to know. The degree measure of a central angle is exactly equal to the degree measure of its intercepted arc. So in looking at this picture here, the intercepted arc is going to be the part of the arc that's bounded by these two radii. So in this particular case, it would be that green arc. Since its measure is 80 degrees, the measure of angle X, the central angle, is also 80 degrees. And again, that's a good thing. That's something you need to know, you need to have memorized. Measure of a central angle equal to the degree measure of its intercepted arc. All right, so we're going to take a look at a couple of examples now. Number one, it says find X in each of the diagrams below. So letter A, they give you a picture that looks like that, and they want you to find X. X is this arc that goes between those 2 points. We do know that the measure of this central angle, and I know it's the central angle because there's the center of our circle, this central angle has measure of 120 degrees. Well, that tells me that the arc that's intercepted by that central angle is also 120 degrees. So the measure of that red arc in the picture is also 120 degrees. I know that the distance from this point to this point is exactly halfway around the circle. So that passes through the center of the circle. A full circle would be 360 degrees. The purple arc is going to be half that, or 180 degrees. So if the green and the red together make up 180 degrees, then the value of X has to be 60 degrees. Notice that I figured out the answer to that question simply by labeling everything I could label in my picture. That's going to be a very important strategy moving forward through this whole unit. You want to make sure that you have a good picture and that you label the picture in such a way that it'll help you find the missing parts or the pieces that you want to find. All right, I'm going to go ahead and take a look at letter B. Again, they're asking us to find x. In this particular case, x is going to be the degree measure of this central angle. We do know that the measure of this red arc is 250 degrees. We can find the measure of this blue arc. The red and the blue together make up a full circle, or a complete 360 degrees. Since the red arc is 250 degrees, the degree measure of the blue arc has to be 110 degrees. And if the degree measure of the blue arc is 110 degrees, the degree measure of the angle that intercepts that arc also has to be that same measure, or 110 degrees. And again, notice that in this particular example, all of our work is done strictly by labeling the picture, or labeling the diagram. All right, so that central angle is the first of two that you really need to memorize from this lesson. You need to know that the degree measure of that central angle is the same as the degree measure of that central, or of its intercepted arc. All right, the second type of angle that you're going to learn about during the course of this video is what's called an inscribed angle. An inscribed angle is an angle with its vertex on the circle, and that's different than our friend, the central angle, and it's formed by two intersecting chords. I'm going to take a minute and explain exactly what a chord is. If I have this circle, a chord would be any line segment whose endpoints are on the circle. So since that purple line segment has its endpoints on the circle, he's a chord. In the picture of the big circle that they give us in this problem here, the chords would be the red line segments. Their endpoints are all on the circle. So because this guy has his vertex on the circle and his sides are made up of chords, he's an inscribed angle, different than the central angle whose vertex would be found at the center of the circle. All right, so again, they're giving us this same picture, and they're telling us that angle ABC is an inscribed angle. And again, that's because his vertex is on the circle. The intercepted arc of this angle is found exactly the same way you would find the intercepted arc of a central angle. You're going to take a look at the two sides of the angle, and you're going to take a look at the arc that's bounded by those two sides. So in this particular instance, the intercepted arc would be that blue arc from A to C, or in other words, arc AC. All right, the second big rule that you need to take away with you from this video is that the degree measure of any inscribed angle is exactly half of the degree measure of its intercepted arc. So when looking at this picture here, the intercepted arc is arc AC. It has a degree measure of 100 degrees. Because this vertex is on the circle and he's an inscribed angle, his degree measure is going to be half of that 100, or exactly 50 degrees. All right, I'm going to take a minute here and have you describe in your own words the difference between a central angle and an inscribed angle. I'm going to leave that to you to finish up because I want that to be in your words rather than in my words. All right, so looking ahead at the top of the next page at the examples, again, they want us to find x in each of the diagrams. And again, we're really going to use these diagrams and we're going to take a look at the pictures and label the diagrams in order to find the requested information. So in looking at this first picture, I noticed that the center of the angle, or center of the circle, is at point A. I'm looking for x. X is going to be the degree measure of this angle whose vertex is on the circle. So that blue angle is an inscribed angle. His degree measure is going to be half of his intercepted arc, or half of the 84, which is 42 degrees. Notice again that all my work here is in the picture, in the diagram. Looking ahead to the next one, the first thing that I'm going to do is I'm going to take a look at the angle. And again, I notice that the vertex of the angle at point D is on the circle. So that makes this angle an inscribed angle. His degree measure is going to be half that of the arc that he intercepts. Well, the arc that he intercepts in this picture is the green arc from B to C, and that makes the green arc from B to C exactly 60 degrees. We haven't yet found what they're asking us to find. They're asking us to find the degree measure of the blue arc from C to D. Well, if I look at this picture, this is a diameter of my circle. It passes through the center, which is at point A. I know that altogether that has to be 180 degrees. Since the green arc makes up 60 of that 180 degrees, the blue arc must be 120 degrees. All right, and then I'm going to flip ahead to letter C, and again the directions say to find X. This question is kind of an interesting question because it contains both an inscribed angle, so there's my inscribed angle, and in addition to that, it includes a central angle. We know that the degree measure of the central angle is 70 degrees. We also know that the degree measure of any central angle is equal to the degree measure of its intercepted arc. Well, its intercepted arc is that red arc right there. Its degree measure, 70 degrees, the same as the intercepted angle. Now, the blue angle intercepts that same red arc, but it's an inscribed angle, and the degree measure of any inscribed angle is equal to exactly half that of its intercepted arc, making the degree measure of the blue angle 35 degrees. Again, notice all my answers are found by labeling the picture, and that's going to be a very key strategy for you as we move through this unit. All right, the last two examples each ask us to find a variety of different angle measures or arc measures, and again, I'm going to find each and every one of them by looking at and utilizing the information that's provided to me in the picture. So rather than start here, I'm going to go ahead and start over here in the picture, and I'm going to label everything that I can label from the diagram. So this angle B here has his vertex on the circle. I know that he is an inscribed angle, and I know that his degree measure is going to be half that of the arc that he intercepts. Well, the arc that he intercepts travels here between points A and C, making the degree measure of that arc 140 degrees. I now know the measure of the red arc is 140. I know the measure of the green arc is 100. The only other arc in this circle is this arc from A to B. Well, if I know that the sum of the three arcs added together have to be 360 degrees, then in order to find the measure of that purple arc, I'm going to add the 100 and the 140 and subtract that sum from 360, and that tells me that the degree measure of the purple arc from A to B has to be 120 degrees. Looking at the other angles in that triangle, if I go ahead and I take a look at angle BAC, I notice that angle A has his vertex on the circle. His degree measure is going to be half that of the arc that he intercepts. Well, the arc that he intercepts is this green guy over here from B to C, and therefore the degree measure of that angle is going to have to be half of the 100, or 50 degrees. I can find angle C in the triangle one of two ways. I can either add 50 and 70 and subtract from 180, or I can say the arc that angle C intercepts is the purple arc, and his angle C's degree measure has to be half of that, or 60 degrees. So at this point, I think I've labeled in my diagram each and everything that they've asked us to find over here. I'm just going to transfer the information from the picture into where they're looking for the answers. But again, notice that all of the work has been completed over here in the diagram. All right, the last one that we're going to tackle together here is example 5. And again, I'm going to kind of ignore all this stuff over here for the time being, and I'm going to move right over to my diagram and start my diagram. We're told that the measure of angle COB is 15 degrees. And if I look at where the vertex of that angle is, the vertex of the angle is at the center of the circle, making this angle a central angle. His degree measure then is going to be exactly equal to the arc that he intercepts. Well, the arc that he intercepts is this red arc from B to C, and that's going to make the degree measure of that arc 15 degrees. The purple arc from A to C and the red arc together have to make up exactly half of the circle, or exactly 180 degrees. And that's going to make the degree measure of my purple arc 165 degrees. The measure of the green arc is going to be exactly half of 360 because he goes half of the way around the circle, or 180 degrees.
This is the line there.
And looking at the picture, there's one angle and one angle only that I still need to find. I need to find the degree measure of angle AOC. And again, his vertex is at the center of the circle, making him a central angle, and his degree measure is going to be equal to the arc that he intercepts. Well, the arc that he intercepts is this arc from A to C, the purple guy, making the degree measure of this angle 165 degrees. So again, I've found everything in the picture. I'm going to transfer over here now, and then I'll be completed with the problem. Or almost. I get down to letter E, and letter E wants to know the degree measure of the arc from A to B to C. So if I go look at that in the picture, there's A. I want to do this arc all the way from A to B and then continue onwards to C. Well, that's made up of the arc whose measure is 180, in addition to the arc whose measure is 15 degrees. So when I combine those two, I end up with 195 degrees for the measure of that major arc. All right, if you have questions or there are things that you don't understand about central or inscribed angles, now would be a good time to jot them down in your notes so that you can remember to ask the next time that you come back to class.